Let's look at the documentation here for the set interface. And we see it brings up quite a bit of information about how set works. As I mentioned, a lot of this you probably want to just browse through or skim, but we do see some methods that are looking a little bit familiar. For example, add. We're able to add something to a list and we can add something to a set. If I click on add, it takes me to the detailed information about add. It's a parameterized type for set just like it was for list. And so we'll add something of the specified type into the set. There is something here about duplication. So this implementation is going to make sure that any implementation is going to make sure that sets never contain duplicate elements. That's one of the things we know is important about a set. So we find, let's see, we found add. What else do we find? Remove we'll find to remove an object. Notice there's no method to remove something at a given location in the set because the set has no order. So we're able to remove an object by mentioning it. If the object's there, it will be removed and true would be returned. We can see the detail of that here. So the return value is true if the set contained the specified element, and otherwise it would be false. So there's remove. We can find out how big a set is. So there's some familiar methods that we find here. Okay, can we find the documentation for the list interface on our own using Google? Well, sure. So let's open up Google and we'll search for if we just search for list, we don't get any, well, actually in this case we got something fairly useful. It took us right where we wanted to go. I would say normally, let's see if I'd ask for set. Aha. So to get something useful, it's often helpful to mention the entire package like Java util set, and then I get to what I want, or Java util list, and then I get to what I want, and here's the API for list. And as you can see, it has add and remove. This will have two removes. It has the remove that removes something at the specified index, but also remove that removes a specific element just like set has. So yes, we're able to find the list documentation just fine. The differences between set and list is we know order is important in a list, not so in a set, and a list can have duplicates. If we look at the documentation again, one of the things we might want to look at are all the known implementing classes. This is where we would look for an actual implementation of a set. We can declare something to be of type set, but that's not enough to implement it. We have to find something that actually implements it. These are listed alphabetically. The one that we really care about here is hash set, and maybe someday we'll care about tree set, but for now hash set is fine. Hash set's the simplest implementation of a set, has everything that we want to in it. Here's its documentation. And so we found that as well. Okay, let's do the coding part. We're supposed to open up the exercise 8 package in the exercises folder and look at the using set class, which is right here. And it tells us to copy everything from using list. Hang on, let me get that back. Well, unfortunately, I didn't save it. So let me just pretend we had done something similar to what we were doing before. It might not be exactly the same. A list of string, and this is our eating stuff, is a new linked list of string. I'm going to pause the video and continue typing to get back where we were before. Let me just do this part. As you recall, we have to mouse over this and find the right implementation to import. And the one we want is from Java util. Okay, I'll be back after I type in more of what we had before. Back, and this is certainly similar to what we might have seen inside using list. If I run it, open mouth, insert food, chew, chew, swallow, digest. And the instructions say simply to copy this and to paste it into using set. But we're going to change list to be a set of string, and we're going to change linked list to be a hash set of string. And now these will have to be included as well. And the idea really is simply just to run this and see what it looks like. So let's run this. Now what we see is something very different in the output. Open mouth, insert food, those are the same as with the first case. But then digest shows up, and then swallow, and we only have one chew. Even though we inserted chew twice here, we only have one chew. So the thing to notice about sets is that the order isn't anything in particular. In this particular case, the first two elements came out the same as in list, but look where Chu ended up, all the way at the end. That's the first thing to notice. And the second thing to notice is that even though we inserted Chu twice, a set's not allowed to have duplicates, and so the second call to add actually should have returned false. Let's see if it did. So I'm going to print out the result of eating.add, and I'll print out this result too. Now I'll just call this first add and second add. Okay, so let's run this. We should see true and then false, and that's correct. The first add was successful. The second add was not successful because Chu was already in there. And finally, let's try deleting something. So if you don't like digesting, let's get rid of that. So we'll say eating.delete.remove, sorry, digest. After delete. And let's see what it looks like. Okay, so after deleting, sure enough, digest disappeared. I believe that is all we had to do for this. Yep. Okay, and then you should commit your work so that you get credit for it.